Okay, so who is Aurrigo? We were established in 1993. We're going to be celebrating 28 years this year. We have global offices around the world, as you can see on the slide. And we have a wholly owned developed ACS control system, and we build our own hardware, meaning the vehicle and dollies and control systems. We are a tier 1 automotive supplier to a lot of OEMs, Jaguar, Land Rover, Bentley, Aston Martin, name a few. And we're accredited through ISO 262 and all the others. So we have currently 4 products in the hardware side: the Autopod 4-seater, the 10-seater Auto Shuttle, and the Auto Dolly, Auto Patrol, and software Auto Sim and Auto Connect on the software side. So just to give you an idea, if you have not seen it, here is our Auto Shuttle, our Auto Pod, and what we're going to talk to more specifically, the Auto Dolly today. Now, what we found when we started going through use cases at the airport, what was the problem? And we were reached out to by British Airways. And some of the things that they wanted to work on were operational efficiencies, things like airplane damage, cargo damage, and safety. So when we talk about the efficiencies, we can essentially create a 70% reduction in when tug drivers are sitting at the terminal waiting for the airplane to come in. And the reason they do that is because when the airplane's at the terminal, it will sit there. And the longer it sits there without being serviced through their window, they get charged, kind of like I guess we'll call it a parking meter. So the longer it's there, the meter goes up and up. So it just keeps, it costs more. That's why everyone's trying to move in and out. So we've been able to increase operational efficiencies using our Auto Dolly from not only people, but the amount of dollies used to operate in that space, storage of these dollies, there's more room available. You can eliminate the tug completely. And so as these things move around, they can also go in their own direction. So instead of being towed into one specific area and then hooked up to other places or to other tugs to go in other terminals, they can just go about their business and head to other terminals. Another thing that we were trying to, the actual main reason we got into this was to solve how airplanes are damaged during this process. The biggest problem that the airlines have is the engines to the airplane are damaged as you tow the ULD carriers on the tugs. They sometimes hit them. And in our 10 weeks initial research at Heathrow with British Airways, 2 alone were hit. And of course, you hit an engine, you're putting the plane out of service, the costs. And because of this, at Heathrow, they actually keep 5 airplanes just in the hangars for this exact issue. Cargo damage is also another factor because everyone's in a rush to get it in a timely fashion to each terminal and deliver and get cargo to its next destination. Sometimes they fall off the back as they round corners and different things like that. You damage ULD, you can endanger people's lives, you damage the cargo inside the ULD, and then of course, again, cost, insurance, all these things go up when you lose goods. Into the safety side, you can eliminate, which has happened worldwide at airports throughout, the decades where people are injured and killed from these ULD and dolly configurations as they're towed away, and they're sometimes not seen. And so, we're eliminating that aspect of it as well. So this was our first configuration that we had at Terminal 5. This was, we ran the ULD carrier before it became Auto Dolly. They gave us every aspect of how an airport runs, from a hardware side to operations side, from where they need to be, when they need to be, what airplanes are coming in, food trucks, honey wagons, all this. It's just a big dance, a choreographed dance on the airport tarmac to make sure all this goes off. But there are so many efficiencies I discussed earlier that we began chipping away and solving the problem and created even a better product than we had originally even hoped for. So when we talk about the use case results, what exactly does that mean? So as far as tug drivers, seeing as you're eliminating the tug altogether, you reduce about 78% of the support needed for that tug, because it's in essence removed. We can remove 100% of the tugs and 72% of the dollies used to carry these things, because they're so efficient with scheduling that they don't have to have the amount required, so your costs fall. And then the health and safety issues, not to mention a lot of these vehicles are diesel, so everything is running on lithium. There's the air quality and all these things from a green standpoint is, unbelievable. So we can utilize the space by reducing the terms of the dollies. At Heathrow, they're not getting any more airport space because obviously land is, it's finite. So we're able to increase the amount of space without increasing the size of the airport available. And we don't have to have manual couplings where, typical train configuration where they're being towed. Once one gets to point, B, it can move to point C without having to wait for, say, the other two or three. So they can move about at their own discretion. So when we look at the market growth for this type of thing, we always talk about the passenger side and where does that lead? Well, the smart airport market is, expected to grow by 30 to 31 billion by 2026, and we're just 5 years off from that. So the business case is there, the cost efficiencies are there, and so we're with the top 200 airports containing 40% of the traffic. Those are the ones that will benefit the most from switching over to automated systems here in the future. And with almost 18,000 airports worldwide, once you start to automate those, your efficiencies, planes are on schedule more often. Packages don't show up late. People get to their destinations on time. All these things ripple throughout the entire industry based off this one little factor. So this is the auto dolly. This is what it looks like. There's a video here. I'll show you in a second. It kind of, to me, looks like a nice Tron-esque design. It's as functional as it is beautiful, and you'll see why right here. So this was designed, obviously, per airport specs and airlines throughout the world. This was the configuration that best suited what they were. So, super proud of the team with the auto dolly. So, I'm not going to get into too many specifics regarding all the aspects of this vehicle and what it will do. But, automated rollers, lighting systems, all this is done in a new way of, normally you map a system and you have to be on location to implement this type of thing. So we created a way to do it without having to actually be on the ground messing with the operations of an airport, because that's just too intrusive. So as you can see here, there's a little more technical data on batteries and endurance, powertrain speeds. all these things that, you know, I don't want to bore you with right at this moment. But as you can see, very robust system, bleeding edge technology. So unloaded, this is what it looks like when it's loaded. It's almost like a piece of art. So your questions about the tech side of things, you know, don't hesitate to throw those in the chat there. But in order to move these things around, it's not just about you know, the vehicle's autonomous. We created a thing called Auto Sim, and I spoke to how we didn't want to be intrusive at an airport by, you know, mapping and getting involved with all the stuff, all the operations of the airport that would be considered intrusive. So we created the Auto Sim, which allows us to map an airport using existing data off architectural plans, 3D maps. Any new airports are all designed in CAD, like you know, airports in the past. It doesn't matter. We can take this data, everything from food trucks to where they need to be, how many loads they have, honey wagons, where those are, our vehicles with the ULDs, the entire operation of an airport. I mean, literally everything. And we put it specific to each you know, airport. We build it out. We can create 3D models, and then we can tell you where the efficiencies, how many ULD auto dollies you'll need, how many you won't need, how many tugs will be eliminated. So we can basically go through an entire spreadsheet of cost savings, time benefits, you name it, all cloud-based that the customer can access. And so we can build this and show you before you even have to start implementing. So it's a really, really cool way to do this, manage this type of system in an airport. So that there is, in a nutshell, how the future of cargo will be delivered here in the future. I'm going to get out of the presentation, and then you can fire away with questions. I'll see them come up. Okay, so one of the questions I have here is, would the Dolly operate on roadways where aircraft might cross? You know, in essence, like something like this on roadways where aircraft might cross, it depends on what the airport requires. Every airport size and how they handle it is just a little bit different. So if they require a specific use case, we can you know, run through the software and determine if it's something that will benefit them, if it's too much of a, you know, stretch in running on roads. But we generally stay in the airport grounds, much the same way the ULDs are now. Wherever they go, we can go. Okay, we've got another question here. So the next steps, what are the next steps for a project like this? So we are working with one of the airports that we're working with in Singapore, Changi Airport. The next steps in terms of what they wanted to do, we had told them what we could do with the Dolly as a hardware piece and how we moved it. And so the first thing they required from us was, hey, can we turn this into, you know, auto sim project and do it without you being here? That was our first test at doing this. And so they, like I said before, they sent us all the data about the airport and how everything operated, from flight schedules to the maintenance schedules to everything else. Put it in the auto sim, gave them the simulation and how it operated, and they were just, you know, over the moon, I guess you could say, with all the money they were going to save and efficiencies. So that was kind of the next step. So if you were an airport, say, you know, ORD in Chicago or, you know, Miami, you would say, we would like to analyze our efficiencies. You show us what you have now. We'll input that into the system, and we can literally begin to chip away and build from point A to point B on the system, where you stand now, and where you can end up, and then we can give you all the data related to, cost savings, to, how many less dollies you'll need, maybe even the vehicles for catering. Maybe we can control efficiencies and where those need to be based on scheduling that maybe it's not working for you as efficiently as you need to now. That's that. So how do you communicate with the dollies? Well, the dollies, one of the things that all the vehicles around an airport have, they have GPS tracking. So in essence, you already know where every vehicle is, but the problem with that is you have one dispatcher trying to, orchestrate hundreds of vehicles, sometimes even nearing thousands, at the airport. So it's kind of who screams the loudest, kind of gets the, information first, or gets the first priority. So there's a lot of mistakes made that way. And so with our dollies, the communication operates kind of similar, using their existing systems, whether it's GPS. Obviously, there's LiDAR and other assets on the vehicle that control its location and real geometry and all these different things. The same as an autonomous vehicle, but a little more fine-tuned for an environment that has a pretty good infrastructure in terms of communication. Okay, how are the cans loaded onto the dolly if you have a dolly that fits more than one can, or do you have a dolly that fits one more can? When they come off the airplane, in a wide body, if they're coming off the side or in the back, they're slid off of, as you see the conveyor, and then it goes straight onto the dolly, just like a manual one would be. And as soon as it's in, it's locked into place. And then the vehicle essentially goes green, and it already has its instructions as where to go before even usually the flights come in, because it has an entire log where it records the entire day's worth of data. Now, if there's a change in a flight, it's canceled, doesn't make it in, that can all be sequenced and rearranged, and then I guess we can say the math happens where the algorithms determine what the next best scenario is. But right now it's one CAN or one ULD per your question. So let me see here. As a company that makes autonomous people moving vehicles and good vehicles, can you share the perspective on how those markets are developing? Which market opportunity is more mature and ready for implementation? I would say that the technology is similar with both, but if you want to say more mature, it all depends on where you're deploying. The thing about deploying in an airport, the security is already there. You don't have randomized, people just showing up, in a path like you do with an autonomous vehicle. There's just the general public can mill around wherever there's an autonomous vehicle run. So like if we have our shuttle or our pod in an implement a deployment somewhere, people get curious about, if you jump in front of it, does it stop? What's the, how much stopping distance does it need? People get really curious about that. In an airport, because it's one of the more secure places on the planet, most airports, it is the easier deployment because there's so many set security rules and structure and how the whole airport operates. I would say it's an easier deployment. Let's see here. How is the maintenance carried out on the Dolly? Is maintenance autonomous too? The vehicle can determine with our ECUs that we have built in. There's a set of algorithm software that determines if there's battery issues, if there's different things that are losing their calibration. And I guess the way to describe it in layman's terms is almost like if you're using your PC or Mac and you run a disk utility, and then you can kind of it can recognize what needs to be adjusted back to its original setting, so to speak. So as these things will be used, you can tell where, just like on a computer, do you need an oil change, where's your battery power, is something out of alignment? All those things are factored in because they're squared at 0 when we deploy them, and so we know what variance it is in either direction if it's starting to become uncalibrated, which, you know, on something like this doesn't really, you shouldn't have to worry too much about. Battery life uptime during the working day. Now that question depends on airport utilization, size of the airport, distance traveled. So there's a lot of these things, like just like if you had any battery operated anything. The one thing that's great about this is you can get 24-hour operation out of them using opportunistic charging is the term for it, where you can have charging pads or stations as the vehicle becomes stationary, or say it's waiting at a terminal, it charges on the deck. So wherever it goes, it can find opportunities when it has downtime where it can charge up. So in essence, you can run these 24 hours a day if you need be. I mean, obviously, if it's running, you know, nonstop, it's going to require a little more charge time and a switch out. But based on what we've seen at the 3 airports that we're at currently, we can run them 24/7 within the given schedule of the flights at those airports. So let's see. Does the operation of the Dolly continue in an indoor setting, or is it strictly just outside? The Dolly, and I'd love to show you stuff on the inside, but most airports have, you can't photograph or film in there, it's illegal. But the stuff you've seen with at the Heathrow Terminal 5, it kind of gives you an idea. It can operate in any weather currently that we've thrown at it, and then it can move into the inside of the airport where it is. And essentially what's going off is it knows where it is based on LiDAR, wheel geometry, GPS, all these different things. And as it moves inside, it just transfers data as to if it does lose GPS, and it has to go strictly with the LiDAR features and wheel geometry. But it can operate in both. We've had some pretty horrendous rain and weather in both Changi and Singapore and Heathrow. We haven't had any issues yet, mostly because the way we built the sensors and how it operates, it kind of eliminates a lot of those chance weather scenarios. Okay. So do you anticipate any benefits from 5G deployments? Currently, everything we're running is with 5G not being ubiquitous, we've gone with the current systems that we have available. And the benefits using something like this is, you can just move a lot more data. The communication, the latency, and everything that's needed to run these, we can do that now with the current systems. So I'm not worried about that. 5G will just give us many more options down the road if we're trying to add features or data streams, downloading information. If there's, everyone's looking for incident reports and things like that. And in order to do that, you've got to download all the things. But because most of it's in the cloud anyways, for operational standpoint, you can monitor that real time, and it creates little addendums to our script if it notices an anomaly or anything like that. So, yeah, I mean, the benefit will be more present when it becomes more ubiquitous, because that's just, there'll be more options that will be available to us. Have you been able to test the functionality in winter conditions? We've done a lot of testing here in Canada. I'm currently in Ottawa, and with our pod, our AutoPod, we've got a lot of information in how it works in winter conditions and ice and all that here. So we've been able to kind of send that back to the home office. That's one of the reasons we came to Canada, is to really be able to test them under all circumstances. And the great thing is with airports, because they are so meticulously maintained to operate airplanes, the snow doesn't pile up like say a road situation here. So you really get a lot of benefits from working in system, because a lot of that stuff is kind of taken care of in essence. Do we have any more questions here? I'm looking for, all right. How long does it start? Okay. How long does it take from when you start to work with an airport through a fully implemented system? And how long does it take for the airports to realize return on investment? Okay, that's kind of a tricky question because it depends on the size of the airport. It depends on what type of data. If it's a new airport, some of these airports are so high tech, they have information that's already digital in essence that we can just, you know, switch right into the system without having to go from analog to digital, so to speak, with, you know, say an older airport. So that takes time. So when you want to run an analysis on an airport, depending on the size, I guess I could say, well, probably 1 to 3 months, depending on the size of the airport. If you're going with like an Atlanta airport or you know, maybe Beijing airport, those are so huge and there's so much, it would probably be on the longer end of things. And of course, with time, this actually gets faster the more we do. Return on investment, we've seen just when we did our first airport, we saw during the first year, just running a minimum amount of the ULD carriers in the system that we have was a $2 million return on investment with a minimal implementation. So I have a bunch of numbers that I could sit here and bore all you with, but reach out to me and I can get very specific, or give me a phone call, and we can really get into the numbers because it's quite dramatic. I mean, we're talking between a 70 and 75% reduction on that cost alone for ULD carriers and moving baggage, which is an enormous amount. So from day one, you're going to start noticing it. Obviously, when you start pulling ULDs out and putting things into service, it's going to take a little bit to see it, but not long at all. Let's see here. How has COVID affected your work at airports and has increased demand? Very good question. With COVID and airports being at basically their lowest service levels in, you know, recent memory, probably since, you know, the industry began, this is actually the perfect time to do like an auto sim analysis on an airport and prepare for the future. Because as we roll out of this in about, you know, they say 2023, when everything really gets back to, you know, pre-COVID numbers, you're going to see this, all the stuff that we've been working toward will be, you know, absolute 100% operational anywhere in the world at this point, as we've done with the 3 previous ones, and that only gets better, obviously, as any technology improves. But yeah, so that's the COVID in a I guess you're going to call it a silver lining sense, because there's a reduction. It gives you the time that you would normally not have, and the ability to maybe, you know, do some stuff at the airport that you wouldn't normally have the chance to do. So yeah, that. So let's see here. Okay, can the auto Dolly be daisy chained? Yes, yes. So daisy chain, in the essence of using a hard drive term on computers, linking them together. We don't have to physically link them together. We created a software system called Swarm, where you can have the lead vehicle, in essence, if it's so with the tug out of it, we can use an ULD as a lead, and the remaining vehicles behind it can follow in daisy chain, if that's that term we want to use here, where they can follow behind the first one, taking orders from the lead vehicle, and then if they need to, as they get to another point, kind of, you know, verge off into a different terminal if they want. But yeah, in essence, daisy chain, no physical connection, tight formation, which, and that's another thing about these that are really cool, is with a wide sweeping, when they're being towed, you need to get a turn, you know, you need a wide berth to get around corners and different things. These things can go at 90-degree angles, so you can open up a ton of free space with these. You know, you're going in and just do a 90 You can't do that to on a regular tug. So that's, even with the companies building auto tugs, you still have the same problem because you're still towing things. So, hardware aside, you're still dealing with that issue. So you can eliminate that altogether. Let's see. Okay. When was your first deployment and what scale did you deploy? Our first, I don't know what I call deployment, but when we first started out was at Terminal 5 for British Airways, IAG. That rolled out, we started replacing a series of, Tug Plus 3, which is the Tug Plus the 3. We replaced that. And from that, we can do one system. We don't have to replace them all. Once we just did the one, we were able to just through, math, I guess, we're able to use that one example and then just repeat it over the airport. We can figure it out. So the one at Changi in Singapore, it's larger. The exact numbers are it's over a dozen, but the same applies to that, just a mathematical, exponential as we increase it, and then you can kind of get your ROI. AutoSim will give that to you already, but then you do the real world testing. You don't need to do a full deployment in order to figure out the benefits or the utilization aspects of rolling this out. That's kind of the benefit of this. You don't have to drop a ton of money to get into the game, I guess, and then you just build it out as you need. Once you get comfortable with how all this stuff. There's a lot of autonomous vehicles and technology. It's a game changer, and there's some adoption to it. Not that there's any issues with our tech. It's just that some people, there's always going to be slow adopters and there's going to be early adopters. And the early adopters, like in Singapore, they're gangbusters. So we're going to see that jump dramatically. So let's see here. What we got here? The 31 billion estimated market by 2026. Does a regional breakdown exist for North America, Canada? The regional breakdown, I do not know. That's kind of like an overarching number they give you. Worldwide, this is what it's looking like. I guess based on the amount of airport traffic, depends on when people come out of line with COVID. I know we're only doing 4 airports in Canada. But with U.S. and Asia and Europe taking most of that, it just depends on how you break the pie up, I guess. And I do not have those numbers. Is there a Canadian trial, the Auto Dolly, yet? No, I've been in talk with the Ottawa Airport throughout the years, whether it's shuttle or pod, Autopod or Auto Shuttle, for moving pilots and staff around from the parking structures to the airport. But because this is new product, we launched last week. We've been working on it for years now. This is kind of a new thing. And so my intent is, to use Ottawa, Hamilton, Toronto, Pearson, all the airports in Canada, and get them online as fast. And we can do that by, like I said, they give us a call and they say, hey, we'd like to analyze the airport and get it, into AutoSim and look at where our efficiencies and our operations stand at now. And then they can do all the tweaks and start, pulling old dollies out and things out of the equation, and then they can start to see where their numbers lie. And so, anyone wanting to get involved in this, that would be the call, and we'd start it out that way, and then you can just start rolling out hardware soon after. So let's see here. So can you speak towards the next steps or things to come for Aurrigo or the Auto Dolly? Aurrigo, one of the things that we prided ourselves as a company is, I guess you could say, kind of like in the Apple computer model, we have our own ecosystem, and that allows us to really take advantage of having our software team and our hardware builds, they sit amongst each other. So when there's an issue or something they want to do, they don't have to go to the manufacturer, so to speak, or have to go to an off-site software team. Our team is all together, and all our technology works seamless together. So we can just move from bit to bit along our ACS and change things. So that's one of the things when you say what's the next step, like that allows us to deploy faster, and because most of the team is from some form of the automotive industry, not only does it run great, but everything's elegant, it's beautiful, and comfortable for passengers, and it's one of those things that just works, and I'm super proud of the guys and gals for all the stuff they produce. So yeah, that's kind of a little overview of Aurrigo and us and logistics. And I hope I didn't talk too fast or not give you enough information, but with time being limited, that's what we're looking at right now. So I appreciate your time and listening to me talk. And so I'm thinking Richard's going to get up here.
Okay. All right. Isn't technology wonderful?
Yeah. It's so I hope that was I didn't skip over anything. Maybe leave a plot hole out, or so to speak. So that you didn't understand some of the things that we do. Is there anything specifically that you can think of?
Chris, it was fascinating, and sometimes, and I know your company's in the business of both shuttles and now goods movement as well. Sometimes shuttles get all the press, right? And real vehicles that do hard work in constrained environments like airport are ones that are market opportunities faster and sooner, depending on the market you're in, as you said. Right, so it's fascinating to see the auto dolly, and thanks for sharing it with us today. For those of you in the audience, we will make both Chris's contact information available later if you have specific questions to follow up, right? As well as this presentation, and a recording of this presentation will be available through the CITM and Durham RTDS websites following the event. Chris, I wanted to thank you. Great work, great job. I know that we worked together to put this together and make it flow. So thank you for the time and effort putting in. And thank you to the engineers on your team for embedding such a pretty cool product. All right. Any last words that you wanted to share? Or?
Yeah, no, I mean, just seriously, just drop me a line, give me a call. I'm available. I would love to, sing the praises and speak the technology, because it's and we're learning more every day. And the great thing about this world is this is the worst it's ever going to be. It's always with tech, right? It's always going to keep getting better and better and better. And so, yeah, the world is going to look dramatically different in the next few years. And I think the cargo side is going to be first. And then as we go, towards the vehicle side and level 5 vehicles, it's super exciting time to be alive.
Yeah, I know that Chris Gillis, who sits in Oshawa, where there's a major goods port, right, marine port, and CITM that sits in Hamilton with a major goods airport, is pretty excited about this concept, and we look forward to getting a Canadian trial underway.
Oh, we can start tomorrow or today, Richard, whatever you want.
Okay. All right, Chris, thank you very much.
Yeah, you're so welcome. Take care, everyone.
Okay.